Hi, Year 8. Today we're just going to continue with area. So the area of a shape is like the way to measure the space inside the shape. So it's just the space inside. Now the ways that we actually measure the space inside the shape is by looking at the number of square units that fit inside the shape. So if you look at this, like that's 1 square unit, because that's like 1 centimetre by 1 centimetre. And then we're looking at, this is just a refresher of what we've done so far, we're looking at how many square centimetres actually fit inside there. And realising that for a rectangle, it is the length times the width. So that's 4 times 3. So like it'll be 4 times 3, so it's 12, and it will be in centimetres squared. So the actual units, and I'd like you just to make sure you've got these copied down, the units for measuring area are basically square units. So you've got millimetre squares. So you've got 1 millimetre by 1, so you've got 1 millimetre squared. Oops. 1 millimetre squared. A centimetre, so you've got 1 centimetre by 1 centimetre, which is 1 centimetre squared. And then you've got a metre by a metre. Now I want you to think about what 1 metre by 1 metre is. 1 metre by 1 metre, which is 1 metre squared, is like, if you get your arm, right, so here you are, stand there, and you put your arm out like this, I find that 1 metre on me is about halfway across my chest, all the way out to my arm. I find that's about 1 metre. So if you stood with people, you could create a metre. If you had 4 people, except you've got a social distance now, so that's probably not going to work. And then you all put your arms out, and one arm to there, one arm to there. That would be 1 metre. So what we're going to do this lesson, we're going to look at using this area, and we're going to take you a little bit further. You did these shapes last year, so what you have already done is we do the square. So with the square, remember the area of the square is just 3 times 3, which is 9 metres squared. The area of the rectangle, so say that was 4 metres and 2 metres, the area of the rectangle would be base times height, which would be 4 times 2, which is 8 metres squared. Then you've got the triangle. So remember we discovered the area of the triangle by cutting out. Some of us did that really well, especially the group that were with me. There was some kids who did that really well. So the area of the triangle is basically half the area of the rectangle. So you can remember it as a half times base times height, or you can remember it as base times height divided by 2. Just make sure that you've got these 3 formulas in your book. We did do one more. I don't know who remembers what that is. Yep, that's right, parallelogram. Okay, so if you look at this, when we're doing the perpendicular height to it, I don't know if you can see the yellow coming up here, but the height must be perpendicular. It's not here, not those sloping sides, it must be like the perpendicular height. So it must be going straight up to have the height. And in saying that, the other shape that we had, the parallelogram, that was just your pushed over rectangle. So the parallelogram looked like that. And if you go like this, okay, there's the height, which is 6 metres, and that's 8 metres. The perpendicular height there is 6. So even if you were given, like, say that was 10 metres, you never use the one on the side there. You never use the sloping height, okay? It must be the perpendicular height. So the area is the base times height, because remember it is the same as a rectangle. And what we did is, remember, if you take this little bit and you put it there, then it will actually look like the rectangle. Remember, we cut that off and put it there. So the area of the parallelogram is 8 times 6, which is 48 metres squared. So that's the parallelogram. Okay, so the new shapes that we're going to do. Now, there is a video there that shows you where the area of this one of these comes from. That's the rhombus. There's a girl who actually created it. You can do that as well, what she's done to show that the area of a rhombus is what I'm going to tell you now. Now, a rhombus, you could do it the same as a parallelogram if you were given the base, given the height and the base, because it's just a parallelogram. But the difference with the rhombus is that all the sides are equal. So it's just a parallelogram with all of the sides equal. Okay, so basically what we do here, when we're looking at this, we go, all right, well, if you are given something else and you're broken up into two triangles, that one there is called the diagonal. If we call that x and we call this one y, then the actual formula you'll see on the formula sheet is a half xy. And what that area is you multiply the two diagonals. So you times x times y, and then you divide by 2. Of course, you can always do the half times x times y. Okay, and really, for the rhombus, that basic formula, like in words, the area is multiply the diagonals, and the diagonals are the things that when you have the rhombus, the diagonals are the things that cross over like that. So you multiply the diagonals and you divide by 2. So that's why you see x times y divided by 2, or a half x y. Okay, you can also see it as a half x y. That's what's usually on your formula sheet. Okay, now when you have a kite looks like the kite that you see in the sky. We did all of these ones last year in Year 8 as well. So the kite is basically the same. So if you've got the x, then you've got the y, which are the diagonals of the shape, the ones that cross over. The area is the x times y divided by 2, or a half xy. So what you basically do is you multiply the diagonals, or the ones that cross, and you divide by 2. Okay, what I would like you to do, I just want you to make sure that you've got all of these formulas in your book, because when you come back next week, I want to see that they're all in there. So then we can go ahead and we can just practice them and use them. So the square is s squared, or you can learn it as base times height. That's the square. That's the base, that's the height. And that's the square. Okay, you've got the rectangle. The rectangle is base times height. See, some of these are pretty simple to remember because they kind of follow the same pattern and the same rule. That's a rectangle. Then you have the parallelogram. The parallelogram is the pushed over rectangle, and the parallelogram is also base times height. And then you have the triangle. So the triangle is half of the rectangle. So it's not the same, it's half of the rectangle. So regardless how you have your triangle, you've got its base, you have its perpendicular height. The area is base times height divided by 2, or you often see it on formula sheets of half BA. Now, so you have two more formulas. You have the rhombus, which is the pushed over square. So the rhombus, which is that. Okay, so that's x and y. So the area is a half xy, or xy divided by 2. And exactly the same formula for the kite, which looks like that. It will have exactly the same formula as the rhombus. So a lot of them actually do have the same formula. You've got to remember which one. You've got to remember that like the square, rectangle, and the parallelogram, they all have that most basic formula, which is base times height. Base times height. When you go to the triangle, think of T for 2. The triangle, you have to do base times height, but you have to divide it by 2. So you think of 2. For the rhombus, that's where you've got to multiply the diagonals. So you're multiplying the diagonals for the rhombus, and you divide by 2. And that is exactly the same formula for the kite, if that was x and that was y. Okay, great. Can you make sure you have each of those formulas copied up, please?